Hi guys, we have this question on pressure and forces. Let's see how we can answer it. So the question reads, in a car lift used in a service station, compressed air exerts a force on a small piston that has a cross section of radius 5 centimeters. So the pressure is transmitted by a liquid to the piston that has a radius of 15 centimeters. So the first question says, what must be the force what force must the compressed air exert to lift a car weighing 13,300 newtons? So we need to find the force that the compressed air exerts on the small piston in order to lift the car weighing this force of 13,300 newtons. So to do that, we're going to need, first of all, to find the pressure, we're going to need, to find the two pressures, we're going to need area. To find area, because remember, pressure is force over area. So to find area, we've been given radius. So since this is a circular cross-section, meaning that we can use the formula for area of the circle, of which we're going to use pi r squared. But before we do that, let's convert the radius from centimeters to meters. I think it will be better that way. So we can say, let's just demarcate here like this. So for part A, we can say we've been given radius, so let's call them R1 and R2. So R1, we've been given 5 centimeters. So this is just the same as 0.05 meters. We've also been given R2. So R2 is 15 centimeters, which is equivalent to 0.15 meters. So we have the radius R1 and R2. Now we can find the area A1 and A2. So we know that area, call it area 1. Area 1 will be equals to pi R1 squared. So if we find the value of pi R1 squared, if we compute this, A1 will be 0.0078 7854 square meters. Again, here we need area 2, which will be given by pi r2 squared. So area 2, if we do the substitutions, we're going to get 0.07 07068 58 square meters. Okay. So now that we have this, to find the force with relation to pressure, we are going to use the Pascal's principle. So according to Pascal's principle, it states that the pressure under a large piston is equals to the pressure under a small piston. So we can write it like this. Let's just do this. Okay, so according to the Pascal's principle, like I said, we can say pressure under large piston. So pressure under large piston, all this is equals to pressure under small piston. So pressure under small piston. Okay, so if that's the case, we're simply saying P1 is equals to P2. So P1 is equals to P2. Now we know that pressure is force over area, so this will give us F1 over A1. This is equals to F2 over A2. Since we're looking for the force 1, remember, is the force exerted by the compressed air. So the idea is, the formula that we have here, F1 is the force exerted by the compressed air, while F2 is the weight of the car. A1 is the area of the small piston, while A2 is the area of the large piston. If you look at the two radii, you can see that that confirms the issue of the small area and the big area. So from there, we can make F1 the subject of the formula. To do that, we're going to cross multiply. If we cross multiply, we obtain F1 times A2 is equals to F2 times A1. So F1 is equals to Let's have it as F2 times A1 divided by A2. We can divide everything by just the same thing. So F1 will be equals to F2. Remember, first two we've been given, it was 13,300. So we have 13,300 newtons. Then if we divide the two areas, A1 over A2, we're going to get 0.1111. Just in there, it recarries. Okay, so the value of F1 or force 1 will be 1,477.8 approximately. So F1 is approximately 1.5 kilo newtons, like that. It's approximately 1.5 kilonewtons. So there we have it. Let's see how we can answer the second question, which says, what air pressure produces this force? So to find this, we're going to say, we know that pressure is equals to force over area, like that. Now, what force are we talking about? The question says, what air pressure produces this force? So the force we'll be using here is the force exerted by the compressed air. So we can say force exerted by compressed air. Force exerted by compressed air divided by area of the small piston. So divided by area of the small piston. Okay, so if that's the case, let's just do the substitutions. So pressure will be equals to the force exerted by the compressed air is the force that we're just from finding, of which we found 1,477.8 divided by the area of the small piston, which was 0.007854, like that. So if we divide the two values, we simply get 1.8, or we can write it as, let's write it as 188,158.9, which is equivalent to 1.88 times 10 to the power 5. Now, since it's times 10 to the power 5, we can say that we can just have it as pressure. I think it's okay like that. Let's just have it as 1.9 times 10 to the power 5 pascals. So that's our pressure. Hence, the required air pressure to lift the car is 1.9 times 10 to the power 5 pascals. So there we have it. Thank you very much. In case you have a question, please feel free to ask in the comments. I'll be happy to respond. Have a good day.